Welcome to In Transit, Climate Change's Commuter Impact Through Data. My name is Indranil Purohit, and I'm here from 2 Sigma Data Clinic. 2 Sigma is a financial sciences company based in New York City, and Data Clinic is a pro bono initiative of 2 Sigma. So we work on data science projects, engineering projects with mission-driven organizations. We're staffed both by full-time people, such as myself, as well as volunteers from around 2 Sigma. We also build tools and other research to contribute to the broader Data for Good movement. We're big believers in open data, and when we work with it, we try to turn it into actionable insights. These 3 steps are how we do that pretty much in every project that we work on, including the one I'm going to talk about today called Trek. We transform the data into a usable format. We present that data in a way that can kind of help guide our partner or our open source consumer to some sort of action. When we develop with a partner, we're building with them and not for them. What that means is we are building collaboratively at every step of the process, from scoping to development to handoff. And if we're working in open source, we try to encourage a community to sort of build on our tools. Like I mentioned, I want to talk about Trek today, which is a tool that combines public transportation data with climate risk data. It was built as part of the Census Bureau's Opportunity Project Sprint in 2023, and we're really excited to show it off today. So when you think of climate risk, and since some of you are joining from DC, obviously flooding is kind of a major example here. So on the left, you'll see here an image from 1970 where buses are clearly stuck driving through floods. And on the right is an image, or rather a video from 2020, where a bus is stuck doing the same thing. The article that I sort of reference at the top here is a great article to check out, and it kind of goes into detail as to how different parts of the city are dealing with and mitigating these flood risks. After we built Trek, though, we realized that DC is not really the only place that has this problem. Across 50 of the largest cities, nearly 60% of bus stops are at risk from climate change. And that's across around 300,000 bus stops that we have in a variety of cities. For transit planners and those working in resiliency, they need prioritization. So it's really important, especially for groups that are more local that have limited resources. So when talking to those groups and understanding what their needs were, we figured out that, well, it's not just enough to show where climate risk stops are. We need to be able to kind of slice that by the use of each transit stop. So in this example here, you can see how going from the total number of stops down to the ones with just high climate risk, down again to the number of ones with both climate risk and vulnerable commuters, really lets you hone in on specifically where the problems might be. The tool Trek that I'm talking about basically lets you do that in this visual format. So it's a web app that lets you sort of search by location, select your filters based on climate risk or sort of the purpose of the transit stop. You can filter by transit line if you want as well. And then you can also, and sort of most importantly, you can filter in this kind of bivariate way, looking at flood risk based on high, medium, or low, access to jobs or hospitals or things like that. Again, high, medium, and low. So I want to walk you through a quick demo of how Trek works. And I'm going to do that by assuming the role of a transit planner that's using Trek. We built Trek to make it easy to understand which locations in a transit network are important to prioritize when it comes to making resiliency improvements. Trek combines climate, transit, geographic, and demographic data to do so. But instead of showing it as numbers, we combine the data and show it as high, medium, and low. The stops are colored accordingly. And on the bottom right, we can see this bivariate filter, which explains on one axis, in this case, vulnerable workers, and on the other axis, our climate risk, which in this case is flood risk. Next, I'm filtering by both of those areas to look at transit stops with a high flood risk and high importance to vulnerable workers. By clicking on a stop, I can see all of its climate risk and all of its transit importance to get a better sense of what matters to transit users who use this stop. I can look at routes that serve this stop to get a sense of the full picture. I'll see the same risks and uses across the entire route. This helps me as a transit planner make better decisions when targeting areas to allocate resources. That's about my time, so I just want to thank everyone for listening. If you want to work with us, please reach out. Maybe if Trek is good for your use case, then that would be great. If you want to check out Trek, go to trek.tsdataclinic.com. If you want to look at our code, it's available there too. And if you have any interest in sort of working with us, reach out and we'd love to talk to you. Thank you.